In this video, we are going to walk through designing aftermarket parts. In this particular example, we have a plastic oil pan that we want to reverse engineer to make it larger, stronger, maybe make it out of a different material, or maybe redesign it completely. And we're going to walk through 3D scanning this and how to turn it into CAD data for downstream applications such as CNC machining, injection molding, casting, or whatever process the aftermarket company wants to use to build a new and different oil pan. Now, to get started, we are going to use a Creaform HandyScan 3D scanner to do the scanning. And the first step in the process is calibrating the scanner. And basically what you're doing is a field calibration, and you're trying to compensate for things like thermal expansion. So, for example, if you take it out into a shop and it's 20 degrees warmer than, let's say, the office it was in, you'll let that acclimate to that temperature, and then you're going to scan this plate, which has known points on it, and it's going to compare those points back to the original factory calibration file, and then do any adjustments in the software to compensate for thermal expansion or anything else. So this just helps make sure that you get the best accuracy out of the scanner. Next, we are going to target the part. Now, many times small parts, you don't need targets. You can see there's a targeted table here. We also have a Lazy Susan that you're going to see. But a part like this is a little tricky. It's got some size to it. It's got some depth to it. So we're actually going to put some targets on it, but we'll definitely take advantage of targets on the table as well. The targets come in a self-dispensing box. There's magnetic, there's sticky, and we've got lots of other tricks we use when we either can't put targets on the part or it just maybe it's a small part, etc. But generally, we're going to put a handful of targets on, in this case, each side of the part, and then we'll get the part set up for scanning. So they come in a light adhesive and a regular adhesive. Depending on if your parts are more oily and greasy and dirty, you might use the heavier adhesive. There's also magnetic if your parts are magnetic. This part's obviously plastic, so we definitely got to put them on them. So we'll put a few on the sides as well, and then put a bunch on the top and then on the bottom. And the idea is just to place them random. You don't want, if theoretically, if they were evenly spaced, the scanner would get confused. But what the targets are for is just positioning of the scanner. It has nothing to do with accuracy. More targets don't make it more accurate. It's just so the scanner can position itself in real time as it moves around. Now, some scanners don't use targets, but you'll find they tend to work slower and they're not as accurate because they're trying to align to the geometry, and you start to get what's called slippage. You don't get good alignments and you lose accuracy. So you can see just a handful of targets on each side of this part, and then we're ready to get started. So with our part targeted, we're getting ready to go here, and you can see just what the targets look like. So just a handful of random targets on the part. So now we're ready to configure the lasers for the part. So we've picked the dark, shiny side of the part, and we've hit auto adjust, and you can see the lasers are getting brighter. So it's going to crank up the laser power and slow down the shutter based on the part conditions, which in this case is dark and shiny. So once it does that, we hit OK. And we've decided the way we're going to scan this part is just scan the top side, flip it over, scan the bottom side. The other way you could do it is try to put the part up on end, but it's a little bit hard to do with this part just because of the shape of it. So this is just easier. And using the little triangles gets the part off the table, as you see here, because we're going to pick up the table as we scan. This will make more sense in a little bit. So to do the scanning, we just push the scan button. And I refer to this often as digital spray painting. So just like spray painting, you get the best results when you hold the device fairly perpendicular to the surface. And so for 3D scanning, you just get a good return back to the scanner, because what it's doing is projecting out these laser lines, and then there's two cameras or sensors that are looking at the distortion of those lines, and through a process called triangulation, it's calculating the 3D space. But you can see how fast it is. But this part is a little bit challenging because there's lots of little kind of nooks and crannies in here. There's some deep slots and crevices. So you got to go over it. You've got to kind of hit it from some different angles and just keep working around. Now, the good news is with this scanner is you can't overscan the part. Even if you keep going over the same areas, it doesn't hurt. But you could certainly underscan it. So you want to just take your time with a part like this and just kind of start working it and angling the scanner in different orientations and work it back and forth and really try to fill that in as good as you can. So you can see, again, just keep working around the part. And that's where this little rotary table is nice. You can kind of just hold your hand in one position or one location and then just rotate it around. And with your other hand, you just kind of slowly rotate the table. So it just makes the scanning a little easier. You're not walking around the table to get to the other side. You hold the scanner about 10 inches away, 10, 12 inches away from the part, and it's got about a 12-inch square area as far as the capture area. If you get too close or too far away, it's just not going to pick up data. So once you're done, you can just hit stop scan, and then we're going to set up for another scan. All right, so we just tell the software we're adding a second scan, and we're going to move our little targets here, our little triangles, and position our part. And again, this is just to get it up off the table. It's not necessarily, but it just saves us from cleaning the data up later. You'll see here shortly. And then we just tell it, same as before, go ahead, start scanning. And you just start scanning away. Now, I've set the resolution here at 0.5 millimeters as the scan resolution. Keep in mind, that's not the accuracy. The accuracy is the accuracy. It's always going to scan at the highest accuracy. The mesh resolution is just the fidelity, when I scan. So I usually set it between 1 millimeter and 0.5 millimeters. The beauty is we save what's called a session file, which has the raw kind of scan data underneath, so to speak. The scanner is always scanning at the highest accuracy and the highest resolution. So as long as you do a good job, take your time scanning, and you fill it all in, you can adjust that resolution later. So if you have a part with real fine detail and you want to, crank the resolution down to, 0.25 millimeters, which would be, thousandths of an inch or so, you can do that. So you can adjust that at any time. Now, like last time, we've got some real intricate detail in here. These little, the little channel that the gasket goes in, we've got to take our time because we're trying to get the bottom of that, but also the sidewall, because we're going to want to cut sections through that later. Same with the hole pattern. We're trying to pick that up. So what's nice, as you see here with the Lazy Susan, is I can just kind of hold my hand in generally one spot and then just rotate the table. So you see here I'm angling over and trying to get that sidewall both on the inside and the outside. So the Lazy Susan is nice to just kind of, otherwise you're kind of having to walk around the part. So any smaller parts we definitely will put on there. Here you can see I'm zooming in. That just helps me see better as I scan. Now as I'm scanning, you're kind of in this lower res mode because it's trying to do this all on the fly. I mean, it looks pretty good, but once we finish it and hit do the final processing, it'll look even better. But it's good enough definitely for me to see that I am filling in that groove quite well and just keep working my way around the part. So, but again, as long as we save our session file, we can always go back and adjust our fidelity, our mesh resolution, as long as we do a good job. So like before I said, you can't overscan the part. You can certainly underscan it. Now, how do you know when it's all scanned? It's really visual. It's looking at it and making sure you have it. So I'm getting the whole inside of the part, but I'm also getting some of the outside of the part because we're going to need overlap to align our two scans here in the next step, okay? But again, we just keep working it. Some of these corners, like you see there, some of that gets a little bit tough because the cameras cannot see the laser because of the way it converges. But overall, we're getting most of the data on this part quite well. And then when we're done, we just hit stop scan. All right, so now that we're done scanning the two sides of the part, we're going to need to basically align them and merge them together. There's a few different ways we can do this. I'm going to use the connect tool and pick the part. And that's part of the reason why we like to lift it up off the table using those little triangles because it does make it easy to separate it. We will inverse the selection, and then we're going to delete everything that you see in this orangish yellow color. All right, so once that's done, we will turn on scan 2, turn off scan 1, and we'll do the same thing here. Select the part, invert the selection, and go ahead and delete it. Delete all of that data. All right, so with that deleted, we are going to go into merge scans. We're going to use manual method. I like that one the best. It's just the easiest or the fastest. So what I like to do is put the part, so you've got the top and bottom scan, just put them in basically the same view. And then you're just picking a few common points. It doesn't have to be perfect, but just kind of close to give it kind of a starting point to start looking. So you can see they're pretty close lined up here. And we'll go ahead and hit best fit. And that's going to now further align them. If you just ask the computer to try to figure this out, it just takes a lot longer. So by giving it a few common points, you can see now it's lined up. We've got a nice, good alignment. When you see the scans bleeding through each other, that's a good sign. And then we just hit merge, and it'll go through now and merge these two scan sets into one. All right, so there it is merged together. And then the last step we're going to do is just get rid of the targets, and there's a few different settings over here. So for example, we can decimate, we can autofill some holes, we can remove isolated patches, that's just stuff floating out in space. So we'll go ahead and set a few of those and go ahead and finalize this. Okay, so now it's done. We can take a quick look at it, and you can see now one thing you'll notice when it autofills these holes on this mesh on the top, we had targets there. I knew this was going to happen, but just to kind of point this out, that's because the target was covering up the area, and it kind of doesn't really know how to fill it in there because of the little notch underneath. Had that been important, we would have not put targets there, but it's a pattern anyway, so it really doesn't matter. So, but here's what our part looks like. We've got our groove, our holes, everything we need. Now the next step is to take it into VX Model. So to do that, we just come up here and click Send to VX Model. And that'll open the VX Model add-on or extension inside VX Elements. And then you can see we've got a whole bunch of new set of icons in here. There's some advanced mesh editing tools. There are some different tools to create some basic geometry, to do alignments, and to do some basic surfacing. So we'll go through some of the common tools that you would use. Now, the first thing we need to do is put this thing in a coordinate system, because right now, if I go to any predefined view, like a top, side, right, it's not in a coordinate system, because when you start scanning, there really isn't a coordinate system. So there's a few ways, there's actually a bunch of ways to create coordinate systems, but the one I use the most is just creating planes, and I'm just going to pick some points. So I'm going to just pick first, we'll set up a plane here right on the top of the part. So I'll pick 3 points. You can pick more if you want. We'll create that first plane, so that'll be right on the top of the part. And then these edges look pretty flat, so I'm going to do the same thing over here. And we'll create a plane, and then finally create a third plane over here. So we'll use these 3 planes now to create a coordinate system. So to do that, we're going to come up here. There's some different alignment systems. We're going to use the entity-based alignment system, and we'll pick plane 1, and then plane 2, and then finally plane 3, and hit align. And now, if we go to a predefined view, oh, we got to turn it off. That's the old scan. We should probably just delete it. Predefined views, you can see here. Okay, so now everything comes into those views, and the planes go along with it. So if we need to, we can use those later. Okay, so now we've got it in a coordinate system, and really what we want to do is start extracting data. And for this, we want to get this groove here, and we want to get these hole locations. So we'll be able to actually do that in one setup. So first step is to come under here and pick cross selection. And we're going to do it to an existing plane, which will be, it could be, let's go ahead and use the origin plane, which is derived from that plane 1, but it's in the proper coordinate system like you see here. And then we move this up and down to where we want to sample the data from, okay? So we don't want it right at the top because, you know, you're going to get a little bit of rounding from the scan data. So we want to sample it down far enough that if we look around, we have all the data we need. So we have our circles, our hole pattern, and we have the groove, okay? So maybe come up just a hair, okay? And we'll go ahead and hit create. Okay, so it's created that, and if we now look under entities, you're going to see this cross section here. Okay, so it might be hard to see, but that's right there. So, you know, what else? So that'll give us our hole pattern, and that'll give us the cross section for the groove. But what else may we want? For example, we've got this notch out here. We've got the bottom of the part. Is any of that important to us? So we can continue to create data. So maybe knowing this profile would also be handy. So let's go ahead and do another cross selection. And again, we'll use that same XYZ origin. But this time we're going to drag it down a little bit farther to right about, let's say, there. You know, or we could run it all the way to the bottom. It really doesn't matter. Let's just take it. Yeah, the bottom of this pan is on an angle, so let's go ahead and put that there. All right, and then last, so we do know this is on an angle. If you look here, you can clearly see it's on an angle. But maybe it's important that we know where the bottom of this pan is. So let's go ahead and extract a plane there. So let's close this. And let's grab a plane, and again, we'll just do a vertex selection. And again, we can pick more than 4 if we want to sample a few more points along here. Okay, and hit create. There we go. So if we go ahead and let's turn off the scan data for a minute and turn on just our entities. So you'll see what we have. We have 2 cross sections and a plane, okay? And we can continue to do this, but let's start with this. So what we're going to do is select plane 4. Actually, yeah, we can do it all in one file. That's fine. All right. So we'll pick these 3 items, and you could do them one at a time if you wanted, or you can just export them all at once. So I'm going to hit export entities, and we will just call this section and plane. And you can go to IJSTEP. There's a few different formats, but basically a neutral file format. Also, right here is a transfer to SolidWorks, Inventor, and Solid Edge. If you have those products, it basically just exports it and automatically opens up that software for you. I mean, it's not really required. You can do essentially the same thing by exporting like I did here. And again, your formats are IJSTEP, CSV, and Autodesk DXF. So all neutral formats that you can work with. Okay, so I have imported that IJS file into Geomagic Design X, but this could be any CAD system: Inventor, Fusion 360, SolidWorks, Solid Edge, you know, AutoCAD. Doesn't matter. It's just going to come in as data. So the plane, in the case of Design X, comes in as a surface that you see over here. and then the sketches just come in as 3D sketches, because basically what they are is just multi-point lines. They are not lines and arcs, and that's the problem with scan data, is you really can't extract a nice sketch with lines and arcs. So we need to reproduce that. So let's start. We're going to hide the plane, and we're going to hide that bottom section and just work with the top. So let's go ahead and do our bolt circle pattern first. So let's get into a top view. And actually, let me go into an ISO for a minute here. And because we've already set up that coordinate system, we've got, the planes accordingly. So basically, I'm going to go into sketch mode. I'm going to select sketch and then select a plane. So this would be pretty similar in most CAD systems. And now I'm basically going to trace over this and create, actual sketches. Because again, this is not a circle. It's just a multi-point line cut through the scan data. So I'll go to the circle command, and there's a few ways we can do this. For the initial one, I'll just pick perimeter, and I'm just going to pick like 3 points on here. And then we can dimension it if we want. So let's pull off a dimension, and the dimension is 0.215. So what should that be? I mean, I really don't know. I'm just going to make it so it pretty much fits. So you can make this whatever you want. And now I want to repeat it. Now, this isn't a clear bolt pattern, so trying to use a linear sketch or circular pattern really isn't going to work here. So it's I'm just going to pick it, copy it, and the way Design X works, wherever you have your cursor, when you hit paste, it pastes it there. And if it's not perfect, you just kind of grab it and move it around and try to line it up. And you could build some, like if these two are supposed to be in line, you could build some construction geometry. Just for this demo, I'm not. When I get them right in line, you see it shows me a little line. So there are some tools to kind of help you. But this geometry is so kind of free floating, or not free floating, but not in a typical pattern. Okay. But I'm copying the exact same radius, and I'm getting it lined up. And again, you're scanning, you're scanning a manufactured part, so things are not going to be perfectly square or round or perpendicular. So a little bit of it is, but you can zoom, if you're not sure, you can zoom way in and just kind of best fit it to that area. Okay, so there we go. We have all of our circles. I mean, if you can imagine doing this by hand, what it would take, and probably take a lot longer, not be as accurate. So there's our first, let's call it sketch one. And, just to kind of show you now that those are all circles, just for example, if I were to go here and extrude them, you can see now we would end up with it. We're not going to at this point, but those would be a solid body, okay? But at minimum, you could export this now as a sketch with actual circle entities. So there's our first sketch. All right, so let's turn back on that section, and let's take a look at it again. Now, the next sketch is going to be this groove here for usually a gasket's going to run in here. This one's obviously going to be a bit more work, just because it's just a lot of geometry. And again, could you take this as it is? Yeah, but it's just a multi-point line, so this is not lines and arcs. So if we want to do this more what traditional CAD, then we need to build those lines and arcs. So let's come in here. It doesn't matter where we start, and we're gonna let's jump out so I can get the plane back on. So every time I do a new sketch, I got to tell it what plane I want to be on. So we're going to do a sketch. We're going to pick this plane, which is at the top again, which is where we want to be. And let's just start here. And so what I like to do is just sketch. So you're just kind of, again, tracing over stuff. And what I like to do is sketch. I don't sketch the corners. What I try to do, is the data in between. Now here we've got a circle, and more than likely, at least this circle or the outer one will share the center point of this one here. It looks like more in the outer one. So for the inner one, I'm going to do the three points again, fit that. And then what I do is I trim off part of the circle. At least in this program, if I don't do that, then it has trouble sometimes figuring out what part of the circle I want to keep. This will make sense here in a second. So now when I go to add my fillet, and what's nice about this is I can do it dynamically, but yet still have it add a dimension for me. And when I go and do this side, if I don't pre-trim that circle, sometimes it gets confused. Okay, so you can see they're different here slightly, 0.42 and 0.43 something. So I can come in and make them all the same if I want. So let's just assume it's wrong amount there. Oh, try that again. 0.43. So now moving forward, if I think they're all going to be that, I can key that in. So let's move down to the next one. So same thing, just draw a flat segment here. Let's go in and do our circle here. And we could do the same with the circle. We could even copy and move the circle over. That might be a little bit faster. But let's go ahead and actually what would be maybe the fastest way to do this. Let's do this real quick here. Let's trim this off. And part of this is just doing it a few times and kind of coming up with a good workflow. So let's do this. Let's actually copy this, and we'll just paste one over here. Although when we go around a corner, I think that's going to give us trouble, but that's okay. So let's go to our fillet, and if we specify value, we'll make this 0.43. So now when we click it each time, we should get that same value. And then what we can do is copy this and paste it over here. This is may not work the best, but grab it here. It's going to move around without a dimension. All right, so let's forget this idea. Again, some of this is just trial and error. I'll spend more time messing around with that, and it'll vary a little bit with your CAD system. Okay. And doing these they just take time. It's just a lot of geometry. It's just lines and arcs, and of course you want everything to be tangent. So it just takes time. Okay, and also not getting lost. Oops. All right, we'll do one more, and then we'll continue on. Okay, so you can see what we've done so far. So it's just repeating that process all the way around. Unfortunately, there's no push button. It's just repeating it. So it'll still take me about probably 10 minutes to walk all the way around. Okay, so there we go. It took about 10 minutes, but you can see everything is now lines and arcs. Everything has the same radius. Pretty much a very exact duplicate of at least that initial line for this slot or this groove. So now the question becomes, can we just offset this? So if we come in here and use our offset command, and let's try 0.135 and pick our profile here and zoom in. Let's try 1.5. So that actually looks pretty good. Now I can see right there, there's something. We'll have to double check it. Is that part of that? Let's go ahead and hit OK. And so there might be a few spots where we may have to add, but still, that saves us a ton of time by not having to redo that whole thing. And again, that's the beauty of having lines and arcs and everything being tangent. Okay, so let's just come in. Where were those at? Okay, so there's one right here. So what we'll do is similar to what we did before. We'll add a perimeter circle. We will throw a line. I guess I could probably, let's try this. I can probably just power trim this out right there. And it's got a slight radius on it. Just fit that in there. 0.088, we'll call it. We lost the other side. That's the problem with that's all right. We can just put it back. When you use that type of trim, it trims off the other side. But so we knew that to be which is pretty much what we used last time. So that gives us that. I think there was another one of these. Yeah, right here. So again, I will just draw a line here and trim it this way. That, and that. And just get rid of that line. Now we should be okay. No, that's right. I'm going to lose it each time. Oh, I need to break that line. So the right way to do this, so let's undo that, is just to draw something here. Do it like that. And trim it. And there may be a better way to do it, but this is just how I do it. Now I've busted that line in two, so now when I do this, we got it. Okay, so let's take a look. We've got one more over here. Okay, so let's assume that's all of them. There may be a few more, but you get the idea. So now we have all this geometry, and again, this is all lines and arcs. And let's just say, for example, we want to extrude down this channel, just to see what it looks like. If I pick that, and yeah, I don't know how deep it is. Let's go 0.125 just to make it a solid body, just for a second. So there's essentially your groove. Okay, so it's really just repeating this process over and over, extracting the information. I'm just going to get rid of that. Building your sketches, and then doing your extrudes, your lofts, whatever. And at any point, we can go back into VX Elements and, extract more information. We can, bring back the mesh, and, let's say, we've got this cutout, we've got this bottom plane. We can cut other sections in any orientation. We can do some surfacing and extract that and bring it in. But that's essentially the process. 3D scan it, bring it into VX Model, put it in a coordinate system, cut sections or extract planes or points or splines or surfaces, and then bring that back into whatever CAD system you want to use, and then basically use that as a guide to then build proper CAD geometry. Because again, VX Model doesn't really create lines and arcs. It just cuts we call them reference sections through the geometry and then lets you go into CAD, because CAD systems can't really import the scan data and do much with it. But that's essentially the workflow.